In this video, we're going to be talking about our second day of law of sines. So before we get into today's lesson, I want you to take a look at the picture on the screen. So we have a coordinate plane and we've got an angle x, which is clearly obtuse. And if you take a look at it, the measure of angle x, I hope you can see, would be 150 degrees, right? Now, there's an interesting thing that occurs here, and what I want you to do is grab your calculator, make sure that you are in degree mode, and I want you to find the sine of 150 degrees, and I also want you to find the sine of 30 degrees and see what happens. If you've done this correctly, you type in sine of 150, you should get that that is 1/2, and when you type in sine of 30, that's also 1/2. And what you should notice here is that 150 and 30 degrees are what we call supplementary angles. And that's going to be important going forward with the type of law of sines that we're going to be working with today. All right, so the portion that we're going to take a look at today is actually known as the ambiguous case. And the ambiguous case is when we're working with a triangle and the given information, if we've got A, B, and C, is if they give you maybe angle A, but then they give you the two sides after it. So if we spell it out, of course, we're going to be careful in how we spell this. I call this the SA case, but we have side-side angle. And if you recall in geometry, this was a special case when you were proving congruent triangles and you called it HL. Well, in this concept, we're not necessarily going to be working with right triangles again. We are in the segment on obliques. So what happens for us when we're working with side-side angle is it's possible to get 0, 1, or 2 triangles in solving it. So can be created. So when you go to solve this, what might happen is because we're missing 2 of the angles, you might get an error as you go to solve, and in that case, it means we can't have a triangle at all, so there's 0. You might be able to just completely solve it the way we normally do and get 1 triangle, and then I'm going to show you in the next couple how it's possible to get a secondary triangle, so there's actually 2 possible sets of given information. So first we're going to practice just finding the number of triangles that can be created. So if we take a look at the first one, we have side A is 2.5, angle A is 37, and side B is 4.6. So if we sketch this out, again, in this case, we don't even know if this triangle works, so it really doesn't matter what your sketch looks like. So 37 degrees is given here. Across from that is the 2.5, and across from your angle B should be 4.6. So that's what we're working with. So clearly side-side angle as we scroll around. In this case, we are going to be given that angle with side opposite, so we know we can set up a law of sines. So we'll have sine of 37 degrees over 2.5, and then we want to set that equal to, in this case, sine of B over 4.6. And note here that we didn't see this at all in our previous lesson where we had to solve for the angle. We were always solving for the side. So same process, we're going to start by cross multiplying. In this case, we'll have 2.5 sine of B equals 4.6 sine of 37. And then we divide both sides by the 2.5, just algebraically getting sine of B by itself. And I'm just going to rewrite, instead of rewrite it, drop it down. But that angle or that fraction would be equal to the sine of B. So in order to find angle B, what we then do is we take the sine inverse of that big fraction. So 4.6. So in your calculator right now, sine inverse of 4.6 sine of 37 all over 2.5. And remember, when you're typing this in, this parenthesis pops up, so you need one at the end to close the 37. Now, what should happen in this case is when you plug it in, it's giving you an error. Because what's happening on the back end, if we were to just type in the fraction, you'd get a decimal of about 1.107, and sine doesn't work for a value over 1. So in this case, there's no possible angle B for the given information, so in this case, there's no triangle. Problem 1 solved. We just had to find the number of, and there were 0 here. So let's take a look at example 2. So this time we have angle C and side A. So getting a quick sketch of our triangle, because again, we don't even know what this is, if this is even possible. So angle C would be 47 degrees, side C is 2.0, and side A is 1.2. So again, we do have side angle. We've got the relationship here that will build our law of sines. So sine of 47 over 2.0, or just 2. And then it would be sine of A in this case over 1.2. So again, going about the solving, I'm going to go fast track it and write what we have to type in the calculator. So we'll do sine inverse of, it would be 1.2 sine of 47 all over 2.0, or again, just 2. And in this case, you get that A should be 26, I'm going to carry a couple decimals, 26.03 degrees. Now, that means that for sure we have at least one triangle. The question is there more? Well, here's how we're going to check. So in the middle here, this sine value that we found here, remember from the beginning we learned that not complementary, supplementary angles have the same sine value. So the supplement of 26.03 is going to have the same sine value, or would be able to produce this same fraction that we got here. So we're going to start by finding the supplement of 26.03. So 180 minus 26.03, and we find that to be 153.97 degrees. So if there is to be a secondary triangle, and when we do end up getting a secondary triangle, we would call this angle that we're finding right now, we'd call it A prime, because it's the second triangle of the original. If that were to be the secondary triangle, the thing we have to keep in mind is that the original information is the same for both triangles, if there is a second one. So the angle C that we had from earlier was 47 degrees. So if I take A prime plus angle C, so that'd be 153.97 plus 47. How we're going to know if this works or not? Well, let's sum those together, and we get a value of 200.97, which, why would that not work? Think about that for a second. Why would that not work? Well, hopefully you said because that's greater than 180 degrees. And if there's only two angles building a value over 180, we know that that can't create a triangle. So there's not at least one triangle in this case, there's exactly one, because the second angle did not allow us to work with another triangle. So let's take a look at example 3 and see what happens this time. So again, we'll start by drawing just a random triangle, because again, we don't even know if this is going to work out. 35 is angle A, across from it is 0.9, and then across from angle B is 1.2. So start by setting up your law of sines. Sine of 35 over 0.9, and then sine of B this time over 1.2. When we solve for B, again, we got to use that sine inverse, and we'd have 1.2 times sine of 35 all over 0.9. When you solve that this time, we get an angle of 49.89 degrees. And that means that there's at least one triangle. So now we go ahead and try to solve for the second one. So I'm going to find B prime, the supplement of the angle we just found. So we'll take 180 minus 49.89, and we get that that angle would be 130.11. So now what we do, we're going to go back and we're going to say, okay, so angle A plus this new angle B prime, we got to total those first. So we'll take 35 was angle A. So 35 plus 130.11. When we sum those together, we get 165.11. Well, that has room, right? That's less than 180. So in this case, there is a possibility that I could find an angle, and I can. I just take 180 minus that total, and that would tell me what angle C prime would be. So in this case, what that means is because there is room, I know that there's going to be two triangles this time. Let me scroll this down. I want you to pause the video and go ahead and try the fourth example. See how many triangles you could create with this one. Okay, so you should have paused the video. And let's check your sketch first. So if this is A, B, and C, C was given as 4.5, 97 was given as this angle, and then across from angle A is 3.9. So here's your law of sines. So set that up first. And then we're solving in this case for angle A because they gave you side A. If you solve this correctly, you should have gotten that A was 59.34 degrees. And now what we do, so that means that there's one triangle for sure. We got to now find out, can we find A prime? Is there room? So we'll take 180 minus 59.34, and we get 120.66. And if this works to make a secondary triangle, then we'll take A prime plus the original angle C and see if there's room left over. So 120.66 plus 97, and when we go to add those two together, that's greater than 180. So didn't work. In this case, there should only be one triangle. All right, so the last thing we're going to do in this lesson is actually solve a triangle using this ambiguous case. So given side-side angle, we're going to find all the missing pieces. And you can see this first example, I'm going to give it away right away. There are two triangles that should work out. So notice here that over on the left-hand side, they're giving you the information, and we're going to find regular sides C, angle C, and angle B. And then I'm going to go over on the other side, and I'm going to put in that we're going to find C prime, C prime, and B prime, because these are for triangle 2. So you can either label it by saying triangle 1, triangle 2 like they did in your notes, or you can put the primes in like I did to show that that is the secondary triangle that will be created here. So first thing we want to do is, again, always draw the sketch. And in this case, you wouldn't know this ahead of time, but I might recommend that you draw two triangles because it'll be helpful when you're solving each individual one to have the information for each piece. So 12, 31, and angle A was what was given. So I am going to go ahead, since again we know ahead of time that this is going to solve to be a secondary triangle. One of these triangles that I just drew is already wrong because there's going to be an obtuse and an acute triangle in this case, but honestly doesn't even matter. So let's start solving triangle 1. So law of sines tells us that we can set up sine of 20.5 over 12. And in this case, I got to solve for angle B first. So sine of B over 31. So take a moment, maybe pause the video, find the value of B, and then come back. In solving that, you should have gotten 64.78 or something close to that. And now the doorway to get us into triangle 2 is to find B prime straight out the gate. So I know in triangle 1, we are working with angle B as a 74.78 degree angle. For B prime, we find that supplement. So when I solve for B prime, I just take 180 minus that 64 value, and we're looking at 115.22 degrees, which if I go back up and double check, I'm not going to write this out, but if we take B prime plus angle A that was given, 115 plus 20.5, that's not over 180, so I know that I can jot that in. So this angle over here would be 115.22, because now I can find the third angles, and you can solve these triangles like full on solve triangle 1, then go over and solve triangle 2, or you can kind of solve each piece as you go, up to you, your strategy. I'm going to find both angle C's and just get all the angles in the triangles right away. So back over here, this was 64.78. And then if we use the triangle angle sum, you should be able to get angle C as 94.72. And then we can do the same thing with angle C prime over here. We'll just take 180 minus the 21 or 20.5 and the 115.22, because that is part of that secondary triangle. And when we subtract those, we're looking at 44.28. so angles all done. Now we just have to solve for all of the missing sides that remain. Okay, so let's go back over to triangle 1. In this case, I can go back and set up the same law of sines that I did earlier, but now I can plug in either angle, well, I can plug in angle C because we already have side B. So I'm going to do sine of 20.5 over 12, and then I'm going to do sine of angle C, which was 94.72, all over, and then this would be little side C, which I forgot to put in the diagram. All right, and hopefully you've already solved for C. You just cross multiply and divide, but when you do that, you should get a value of approximately 34.15, and we are working in meters here. And remember, again, triangle theorems show that the smallest angle is across from the smallest side. So as you're working through, be checking all of those logic checks, all the things you know to be true about triangles, just to make sure that you're on the right track. So 34 makes sense as that side because it is across from the largest angle. So that actually finishes out triangle 1. Now we just have to do the same thing but solve for triangle 2. And actually, I'm going to do identically the same thing. Sine of 20.5 over 12, because that's still the given information, so it's in triangle 2 automatically. And then this time, angle C, I'm going to swap out to the 44.28 over C prime. So go ahead and solve for C prime, get the value there. And you should get 23.92. And again, this is in meters. Okay, so no different than solving law of sines the way we did it before. We just have to do more work in the event that there is a secondary triangle. And again, the test to determine that is right here. As soon as you solve for that first angle, because that's what you have to solve for when you're given side-side angle, you find the supplement and see if it opens the ability to build a secondary triangle. So I'm going to scroll down here and give you one more example. See what you can come up with on this one. See if there's, again, start by determining if it's a 0, 1, or 2 triangles. If it's 0, your work is cut short. If it's 1, then you know what to do already. And if it's 2, then it's right like what we just did. You can follow the steps on that. So pause the video, try this one out, and then come back to see how to do it. All right, so you should have started by sketching this so we have an idea of what we're looking at. I'm not going to draw the second triangle yet because there's a possibility that this doesn't even work. So 85 for angle A, 15 for side A, and side B is the other side that was given. So law of sines tells us we can set up that ratio. So we'll have sine of 85 over 15, and we are going to have to solve for B, and that's over 25. So remember, to solve this guy, you're going to do sine inverse. I'll write in the fraction here. That'll be 25 sine of 85 all over 15. And what happens when you type all that into your calculator? Well, it gives you an error because if you just type in the fraction, this is one way to check it. If you type in this fraction, you should get 1.66, and that's too big. So in this case, you lucked out. There's no triangle to solve here, so your work is done. And my triangle here looks a little more like a D than a triangle, so no triangle. There we go. No triangle here, so our work here is done. We don't have to solve a secondary one. All right, so go ahead and practice this. Keep working on these problems in your problem set, and good luck. Let me know if you have questions.